This is the Process Analysis with Multiple Flow Units question for the Process Analysis Module practice problems. There are 3 products produced by 5 resources, and each resource works 8 hours per day. Product A has a demand of 40 units per day. 40 units per day divided by 8 hours per day equals 5 units per day, so each resource must produce 5 units per hour to satisfy demand. Similarly, product B has a demand of 50 units per day. 50 divided by 8 is 6.25, so demand is 6.25 units per hour. Finally, product C has a demand of 60 units per day. 60 divided by 8 is 7.5, so demand is 7.5 units per hour. The first question asks us to find the bottleneck. To do this, we create a generic flow unit, which is 1 minute of work. Then we must find the capacity and total workload of each resource. Now, the capacity of each resource is determined by the number of workers. It is simply the number of workers times 60, since we are looking at the capacity in 1 hour. The total workload is the processing time for product A times the hourly demand for product A, plus the processing time for product B times the hourly demand for product B, plus the processing time for product C times the hourly demand for product C. Once we have the capacity and the total workload, we can calculate the implied utilization, which is simply total workload divided by capacity. The resource with the highest implied utilization is our bottleneck. Let's calculate these values for each resource. For resource 1, capacity is 2 workers times 60 minutes per hour, which equals 120. For resource 2, a similar calculation gives us 120, and we can do the same calculations for the remaining resources. Now let's calculate the total workload. For resource 1, the total workload is a processing time of 5 minutes per unit for product A times 5 units per hour plus 5 minutes per unit for product B times 6.25 units per hour plus 5 minutes per unit for product C times 7.5 units per hour. Summing this gives us 93.75. For resource 2, the total workload is 4 minutes per unit for product A times 5 units per hour plus 4 minutes per unit for product B times 6.25 units per hour plus 5 minutes per unit for product C times 7.5 units per hour. Summing this gives us 82.5. For resource 3, the total workload is 12 minutes per unit for product A times 5 units per hour plus 0 for the other values. This gives us 60. For resource 4, the total workload is 3 times 6.25 for product B plus 3 times 7.5 for product C plus 0 for product A, which sums to 41.25. And finally, for resource 5, the total workload is 6 times 5 for product A plus 6 times 6.25 for product B plus 4 times 7.25 for product C, and this sums to 97.5. Finally, we can calculate the implied utilization for each resource. For resource 1, 93.75 divided by 120 is 0.78125, or 78%. For resource 2, 82.5 divided by 120 is 0.6875, or 69%. For resource 3, 60 divided by 60 is simply 1, or 100%. For resource 4, 41.25 divided by 60 is 0.6875, or 69%. And for resource 5, 97.5 divided by 120 is 81.25, or 81%. Then the highest implied utilization is 100% at resource 3, so resource 3 is our bottleneck. Finally, to determine the flow rate for each unit, note that the highest utilization is less than or equal to 100%, so this process is demand constrained. This means that the flow rate is determined by demand. So, as we calculated above, the flow rate for product A is 5 units per hour, for product B it is 6.25 units per hour, and for product C it is 7.5 units per hour.